A wonderful day, learners! Today is another exciting and fun-filled learning experience here in the world of science. Before we begin to our discussion, let us have a few reminders for this session. Number 1, focus to our topic. By focusing to your topic, it will give you more learnings and understanding of the topic that you study. Number 2, participate in the activity. It is more enjoyable and exciting if you participate in the activity. The more you participate, the more you learn. Lastly, number 3, be honest all the time. You will feel a pure success if you do our task honestly. Alright learners, I know you are now equipped with the simple guidelines of our session today. Let us now start our discussion. Hello learners! Here we go again, and I know you are all excited to know more of our topic today. But before we start our discussion, let us have a quick review of your past lesson. I will ask you 3 questions and comment your best answer in the comment section below. Take note that you must be honest all the time. Are you ready? Let us start. Number 1. How many protons are there if the atomic number of an atom is 25? You have 10 seconds to answer, and the timer starts now. Alright, time is up. The correct answer is 25. This is number 2. What is the atomic mass of an atom if the number of neutron is 8 and the atomic number is 9? You have 10 seconds again to comment on your answer, and the timer starts now. Alright, time is up. The correct answer is 17. And for the last number, number 3, atomic number is always equal to... The timer starts now. Alright, time is up. The correct answer is number of proton. Good job, learners! You got all the correct answer. Alright, learners, before we start our lesson, let us identify our objective for today. The objective for today is determine the electron configuration of a particular element, and lastly, write the electron configuration of a particular element using its core symbols. Okay, let us now proceed to our topic, which is electronic configuration of an element. In the previous lesson, you have learned about physical changes in terms of the arrangement and motion of atoms and molecules, and how to determine the number of protons, electrons, and neutrons in a particular atom. For this lesson, you will learn to clarify the different elements in relation to its electron configuration and the different trends in periodic table. I have a question for you. Have you ever wondered why there are things which cannot be joined together, like oil and water, for example? That is because different atoms have their own properties that determine the chemical reactions the atom can participate in. The electronic configuration of an atom determines the chemical reactions the atom can participate in and determines the kinds of molecules that atoms can combine into to form more complicated substances. The periodic table of elements is a guide chart used to easily determine the different characteristics of an element and also can be used to predict the chemical behavior of an element based on the position or where an element is located. The elements in periodic table were arranged according to its increasing atomic number developed by Henry Moseley from hydrogen 1 to oganesson 118. Alright class, I have a question for you. How will you determine the electronic configuration of an element? But before I answer that, let us have a sample electronic configuration. Take a look at this example. As you can see on this example, number 2 represents the principal quantum number of shell or the principal energy level. But what is principal energy level? Take a look at this element. As you all know, every element or atom has orbit where the electrons of an atom is located. The principal energy level serves as the orbit of an atom. The first orbit has a less energy level. An orbit that is far from the nucleus of an atom gets a higher energy level. The higher energy level of an atom is 7. Now class, the letter P on this example is the subshell or blocks. The subshell is the location of elements in the periodic table. There are 4 subshell in the periodic table, and these are S, P, D, F. The S block is located on this part of the table or the periodic table. The D block is on this location. The P block is on this part. And the F block is on this part of this periodic table. Each block has a column where you can find the group of elements. The first column is the first group and so on and so forth. By the way, the meaning of SPDF is S means sharp, P means principal, D means diffuse, and F means fundamental. Now class, the number 6 on this example represents the number of electrons of an atom. Every subshell has a maximum number of electrons per subshell. For S, the maximum number is 2. For P, 6. For D, 10. And for F, 14. Now class, go back to my question. How will you determine the electronic configuration of an element? Take a look at this example. Oxygen has this electronic configuration which is 1s2, 2s2, and 2p4. How oxygen came up with this electronic configuration? The answer is this. There are two methods in order to get the electronic configuration of an element. The first one is long method, and the second one is short method. In long method, all electronic configuration of an element are written. In the given example a while ago, the electronic configuration of an oxygen, which is 1s2, 2s2, 2p4, is a long method. But how do we get this? We will use a technique called the Christmas tree model or the chemistry model. Now, how do we use this Christmas tree model or chemistry model? Now, listen carefully because I will explain the use of this model. Now, for this example, the first electronic configuration is 1s and the superscript for that is 2 because S or the S block or the subshell S has a maximum number of electrons which is 2, while the other subshells P for 6 which is 6, D which is 10, and F which is 14. So those are the maximum number of electrons per subshell. Now, as you can see, there is an arrow that connects every electronic configuration. That arrow represents the flow of electronic configuration or the sequence of electronic configuration if you're going to write the specific electronic configuration of an element. Now, the first electronic configuration, as I've said a while ago, is 1s2 followed by 2s2, 2p6. Next is 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, and 7p6. The last electronic configuration is 7p6. Now, I hope you follow the pattern or the sequence of electronic configuration using the chemistry model. Now, let's have an example. For example, DSi or silicon. In the periodic table, the atomic number of silicon is 14. Now, what is the electronic configuration using a long method of this element? Now, we will use this chemistry model or Christmas tree model. Alright. Now, I will show you first the answer for this. The answer for this is 1s2, 2s2, 2p6, 3s2, 3p2. Now, how this electronic configuration come up? Now, let us find out. 1s2, as you all know, or as I've said a while ago, is the first electronic configuration or the start of the electronic configuration sequence. Now, here is the 1s2. Now, the arrow, as you can see on the chemistry model, represents the flow of the sequence of the electronic configuration. So, what is the next electronic configuration? The next is 2s2, followed by 2p6, 3s2, and the last is 3p2. Why it stopped in 3p2 and why the superscript or the number of electrons in the subshell P is 2? Alright, the answer is this. If we're going to total the number of electrons of all electronic configuration on this example, you will come up with a total of 14. Alright, as you can see, the P block is located at the right side of the periodic table. Now, the last electronic configuration of our given example, which is silicon, is 3p2. Now, the subshell is P. So this is P, wherein it is located at the right side of the periodic table. And the 2 or the electrons in the given electronic configuration represents the group number. So the group number of silicon is 2. So that is why our answer in the given example is correct. Did you get the idea? Oh, I know you do. Now, let us continue our discussion of electronic configuration. Now, how about short method? How do we use a short method? Short method is an electronic configuration of an element are written using core symbols. So meaning, if we're going to use a short method, you will use a technique called core symbols. Core symbols is used if the atomic number of an element is too much higher, like Hg or mercury, which has an atomic number of 80, and so on and so forth. Now, how do we use a core symbols? In core symbols, it uses the noble gas element plus the next electronic configuration. Now, take a look at this example. The example is Ba or barium. Now, in long method, the electronic configuration of this is this. Alright, as you can see, there are a lot of electronic configuration on this. Now, in short method, you're going to write only this. Alright, as you can see, there are only two terms on this, the Xe and 6s2. So this is the short method of barium or Ba. Now, this part is the electronic configuration of Xe or xenon. Meaning, if we're going to use, again, I repeat my explanation, if we're going to use a core symbols, a technique in short method, you're going to write the noble gas or the nearest noble gas to the given element, followed by the next electronic configuration. So that is why xenon is the given noble gas for this example. And the next electronic configuration is 6s2. Now, take a look at this example. This is a technique wherein you will find easily the specific noble gas in a given example. Now, on the right side of the chemistry, as you can see, the P block are there. That is the location of the noble gas. If you're going to compute the number of electrons, you will come up the exact number of electrons for each noble gases. Now, in the given a while ago, which is barium or Ba, Xe is the nearest noble gas of this element. Now, did you get the idea? Oh, I know you do. Alright, so I want to test your idea. We will be going to have an activity. Okay. I will be giving you 3 minutes in order to answer this given table. Now, please be honest in answering this table. And the timer starts now. Alright, time is up. Let us now show the correct answer. And the correct answer is this. 1s2, 2s2, 2p6, 3s2, and 3p5. And for the next item, which is scandium, The answer for the short method is this. AR 4S2 3D 1. Alright learners, congratulations if you got all the correct answers. Now, I suggest you to repeat this video again if you didn't understand or get our discussion for today. Alright learners, thank you for watching our session today. I hope you learned and enjoyed this session. Again, this is Mr. Rogelio Rivera, your science teacher. See you on another exciting learning experience here in the world of science. Take care and God bless!